The year is 1916, and across the muddy hellscape of the Somme, a new kind of monster crawls into history. The British Mark I tank lurches forward through the barbed wire and shell craters, its rhomboid shape designed to cross trenches that have swallowed entire battalions. Inside, 8 men sweat in temperatures exceeding 100 degrees Fahrenheit, choking on carbon monoxide fumes as the engine roars. The tank's top speed is barely 3 miles per hour, slower than a walking man, but to the German soldiers watching this mechanical beast approach, it might as well be an unstoppable demon. The Mark I represents humanity's first attempt to break the stalemate of trench warfare, a 28-ton answer to machine guns and barbed wire. Its armour is only 12 millimeters thick, enough to stop rifle bullets but little else, and its armament consists of either 2 6-pounder guns or 4 machine guns, depending on whether it's a male or female variant. The Mark I's battlefield debut is chaotic and plagued with mechanical failures, with only 25 of 49 tanks reaching their objectives, but the psychological impact is immeasurable. This lumbering giant proves that the age of cavalry charges is over and the age of armoured warfare has begun. By 1940, tank design has evolved dramatically, and the German Panzer IV exemplifies the lessons learned from 2 decades of innovation. Unlike the Mark I's ungainly shape, the Panzer IV features a more conventional design, with a rotating turret and a crew of 5 working in relative coordination. This medium tank becomes the workhorse of the Wehrmacht, serving on every front from the deserts of North Africa to the frozen steppes of Russia. Its 75mm main gun can pierce most Allied armour in the early war years, and its relatively reliable Maybach engine gives it a respectable range of 125 miles. The Panzer IV's importance lies not just in its combat capabilities, but in its adaptability. Over the course of the war, it receives constant upgrades to its armour and armament to keep pace with enemy developments. German tank crews learn to use the Panzer IV in combined arms tactics, coordinating with infantry, artillery and air support in a doctrine called Blitzkrieg. The tank's sloped armour and relatively low profile make it harder to hit than earlier designs, though by 1943 it begins to face increasingly superior Soviet and American tanks. The Panzer IV remains in production throughout the entire war, with over 8,500 units built, testament to its fundamental soundness as a design. On the Eastern Front, the Soviet T-34 emerges as perhaps the most influential tank of World War II, a design so effective that it catches the Germans completely by surprise. When the Panzer divisions first encounter the T-34 in 1941, they find a tank that outmatches their own in almost every category. Better armour, better gun, better mobility. The T-34's sloped armour is revolutionary, angling the steel plates so that enemy shells are more likely to deflect rather than penetrate, effectively doubling or tripling the protection compared to flat armour of the same thickness. Its wide tracks distribute weight across a larger area, allowing it to traverse mud and snow that would bog down German tanks, while its diesel engine is less likely to catch fire than gasoline engines and performs better in extreme cold. The 76mm gun can destroy any German tank at the start of Operation Barbarossa, and the tank's simple, rugged design means it can be produced in enormous numbers and maintained by poorly trained crews. Soviet factories churn out over 80,000 T-34s during the war, more than any other tank in history, and its influence extends far beyond 1945, serving in conflicts from Korea to the Middle East well into the 1990s. The Americans bring their own philosophy to tank warfare with the M4 Sherman, a medium tank that prioritizes reliability and ease of production over raw combat power. The Sherman's designers understand that the tank needs to be simple enough for drafted civilians to maintain and operate, rugged enough to survive being shipped across oceans, and cheap enough to build in the tens of thousands. With its 75mm gun and gasoline engine, the Sherman is outmatched by German heavy tanks like the Tiger and Panther in direct combat, leading to the grim nickname Ronson after the lighter company's slogan, "Lights first time, every time." But the Sherman has advantages that don't show up in armour thickness charts. It's mechanically reliable, easy to repair with standardized parts, and available in overwhelming numbers. American tank crews learned that while one Sherman might lose to one Panther, 5 Shermans working together can usually destroy it through flanking maneuvers and coordinated fire. The Sherman's versatility leads to countless variants including tank destroyers, recovery vehicles, and flamethrower tanks, and its chassis forms the basis for dozens of specialized vehicles. By war's end, nearly 50,000 Shermans have been produced, equipping not just American forces but British, Soviet, and Free French units as well. The German response to Soviet armor superiority comes in the form of the Tiger I, a 54-ton behemoth that represents the ultimate expression of heavy tank philosophy. The Tiger's 88mm gun, derived from the legendary anti-aircraft weapon, can destroy any Allied tank at ranges exceeding 2,000 meters, well beyond the effective range of enemy return fire. Its frontal armor is 100mm thick and nearly impenetrable to standard Allied anti-tank weapons, making it a rolling fortress that dominates every battlefield it appears on. But the Tiger is also phenomenally expensive to build and maintain, requiring hundreds of man-hours of skilled labor and consuming fuel at an alarming rate. Only 1,347 Tigers are produced during the entire war, compared to tens of thousands of Allied tanks, and their mechanical complexity means they frequently break down far from spare parts and trained mechanics. Tiger commanders become celebrities in the German military, with aces like Michael Wittmann credited with destroying hundreds of enemy vehicles. But strategic reality means these formidable machines can never be numerous enough to change the war's outcome. The Tiger represents the German preference for quality over quantity, a philosophy that produces superior individual vehicles but ultimately fails against the Allied strategy of overwhelming numerical superiority. The Cold War transforms tank design once again, and the Soviet T-54-55 series becomes the most produced tank in history, with over 100,000 units built. This medium tank incorporates lessons from the T-34, while adding new features like a more powerful 100mm gun, thicker armor, and improved mechanical reliability. The T-54's low profile makes it a difficult target, standing only 7 feet tall compared to nearly 10 feet for contemporary Western tanks, and its simple, robust design allows it to operate in conditions that would disable more sophisticated vehicles. Soviet doctrine emphasizes mass tank formations that can overwhelm enemy defenses through sheer numbers and speed, accepting higher casualties in exchange for rapid territorial gains. The T-54 serves in dozens of armies around the world, fighting in conflicts from Hungary to Vietnam to the Middle East, and even today examples remain in service with various militaries. Its influence on tank design is profound, establishing the Soviet approach of favoring mobility and firepower over crew comfort, and establishing the hemispherical turret shape that becomes standard for Warsaw-Pact armor. Western tank development during the Cold War focuses on technological sophistication, exemplified by the American M60 Patton series. Entering service in 1959, the M60 features advanced fire control systems, optical rangefinders, and eventually infrared night vision equipment that gives American crews significant advantages in target acquisition and accuracy. The M60's 105mm rifled gun fires sophisticated ammunition types including armor-piercing, fin-stabilized discarding sabot rounds that can penetrate Soviet armor at long ranges, while its diesel engine provides good operational range without the fire hazards of gasoline. American doctrine emphasizes well-trained crews using superior technology to achieve first-shot kills from defensive positions, accepting that NATO tanks will be outnumbered by Warsaw-Pact forces in any European conflict. The M60 serves as the US main battle tank through Vietnam, the Yom Kippur War, and numerous smaller conflicts, with over 15,000 produced for American and Allied forces. Its design philosophy of combining firepower, protection, and sophisticated electronics establishes the template for all subsequent American tanks, prioritizing crew survivability and technological edge over raw numbers. The British contribution to Cold War armor comes in the form of the Chieftain, a heavy tank that emphasizes protection and firepower while accepting limitations in mobility. The Chieftain's 120mm rifled gun is the most powerful tank weapon in NATO during the 1960s and 70s, capable of destroying Soviet tanks at ranges exceeding 3,000 meters, and its advanced armor design using composite materials provides excellent protection against both kinetic and chemical energy weapons. British designers positioned the driver in a reclining position, allowing the hull to be lower and presenting a smaller target profile, while the tank's fire control system includes a ballistic computer and laser rangefinder that give it excellent first-shot hit probability. However, the Chieftain suffers from chronic engine problems with its Leyland L60 multi-fuel power plant, limiting its strategic mobility and operational readiness. Despite these issues, the Chieftain serves as Britain's main battle tank for over 2 decades and is exported to numerous countries including Iran, where it sees extensive combat during the Iran-Iraq War. The Chieftain's emphasis on long-range gunnery and heavy armour protection influences subsequent British tank designs and demonstrates an alternative approach to the Soviet mass production philosophy. Modern tank warfare reaches its apex with the American M1 Abrams, a third-generation main battle tank that combines revolutionary technologies into the most capable armoured vehicle ever built. The Abrams features composite armour, incorporating depleted uranium mesh that provides protection equivalent to over 600 mm of conventional steel, making its frontal arc virtually immune to most anti-tank weapons. Its 120 Patton smoothbore gunfires, sophisticated ammunition including depleted uranium penetrators that can punch through any known armour at combat ranges, while its turbine engine generates 1,500 horsepower, giving the 60-ton vehicle surprising speed and acceleration. The Abrams fire control system includes a thermal imaging sight that allows crews to identify and engage targets in complete darkness or through smoke and dust, a laser rangefinder that provides instant accurate range data, and a ballistic computer that calculates firing solutions accounting for range, target movement, wind, and ammunition type. During Operation Desert Storm in 1991, Abrams tanks engage and destroy hundreds of Iraqi T-72s and T-55s, often from ranges where the enemy cannot effectively return fire, demonstrating the overwhelming advantage of superior technology combined with well-trained crews. The Abrams continues to serve as America's main battle tank today, constantly upgraded with improved armor, electronics, and ammunition to maintain its battlefield dominance against evolving threats. The Soviet answer to Western technological superiority comes in the form of the T-72, a main battle tank designed for mass production and ease of operation by conscript crews. The T-72 features an autoloader that reduces the crew to 3 men and allows a higher rate of fire than Western tanks requiring human loaders, while its 125mm smoothbore gun fires powerful ammunition including anti-tank guided missiles. The tank's composite armour provides reasonable protection against Western weapons, and its low profile continues the Soviet tradition of presenting a small target on the battlefield. Most importantly, the T-72 is designed to be manufactured in enormous numbers by semi-skilled workers using simplified production techniques, with over 25,000 units built in the Soviet Union and licensed production in numerous other countries, bringing total numbers to perhaps 50,000. However, the T-72's design includes fatal compromises. Its autoloader stores ammunition in a carousel beneath the turret, meaning a penetrating hit often causes catastrophic explosion and total crew loss, while its fire control systems are generations behind Western equivalents. The T-72 fights in numerous conflicts from the Iran-Iraq War to Chechnya to Syria, usually suffering heavy losses when facing modern Western tanks, but proving effective against less sophisticated opponents. The T-72 represents the culmination of Soviet tank philosophy: simple, cheap, and available in overwhelming numbers, accepting higher casualties in exchange for strategic mass. The Israeli Merkava represents a unique philosophy in tank design, prioritizing crew survival above all other considerations. Following heavy tank losses in the 1973 Yom Kippur War, Israeli designers create a main battle tank with the engine mounted in the front, providing additional protection for the crew compartment and featuring heavy modular armor that can be quickly replaced after battle damage. The Merkava includes a rear door that allows wounded crew members to be evacuated under armor or permits infantry to ride inside for urban operations, turning the tank into a hybrid infantry fighting vehicle when necessary. Israeli doctrine emphasizes that trained crews are Israel's most valuable, military asset, and losing them is unacceptable, so the Merkava sacrifices some firepower and mobility for superior protection, including trophy active protection systems that can intercept incoming anti-tank missiles. Combat experience in Lebanon and Gaza proves the Merkava's effectiveness, with crews surviving hits that would have been fatal in other tanks, and the design philosophy influences tank development worldwide. The Merkava demonstrates that there is no single correct approach to tank design. Different nations develop different solutions based on their strategic needs, operational doctrine, and the specific threats they face. Tank warfare enters the 21st century facing new challenges and evolving doctrines that question the relevance of heavy armor in modern conflict. The American experience in Iraq and Afghanistan sees M1 Abrams tanks deployed in urban environments against insurgents using improvised explosive devices, rocket-propelled grenades and suicide bombers rather, than enemy armor. Tankers learn to operate in city streets where engagement ranges shrink from kilometers to meters, where threats come from above and below as well as horizontally, and where the psychological impact of a 60-ton armoured vehicle can be as important as its firepower. Tank designs evolved to address these new threats with additional armour packages, protecting the sides, belly and rear against IEDs and ambushes, active protection systems to intercept RPGs, and improved optics allowing crews to scan for threats in 360 degrees. The urban warfare experience demonstrates that tanks remain relevant, but must continue evolving, incorporating new technologies like artificial intelligence for threat detection, active camouflage systems, and drone integration. The future may see unmanned tanks controlled remotely or autonomously, but the fundamental concept of protected mobility and overwhelming firepower that was born on the Somme in 1916 continues to shape warfare more than a century later, proving that the tank remains one of the most influential military technologies ever created.